Good afternoon, everyone. Hi, nice to see you. Let me just turn the light on. Sorry, it's quite dark in here. Hope you're all well. Today we're going to be doing some slightly less theoretical things, which is super exciting because I know some of you are getting kind of exhausted by all the treesy stuff that we've been doing. Firstly, welcome to week 4. As I said in my notice, congratulations to everyone for surviving this far. And I guess you've all got how long till you can drop out? You've all got 5 days till you can drop the course and run away forever. Though I don't think you can avoid the course. So if you're doing okay, you should always stick it on. And yeah, I think trees are probably a good example of like, if you can wrap your head around trees, I think you'll be okay for the rest of the course. So if you're one of those people right now who's kind of watching this, and you're not sure how you're feeling, I would probably recommend playing around with the exercise code from week 3 with the trees, just kind of all of this stuff here in exercises. Because if you can kind of get your head around that, you'll probably feel a lot better about everything. So, but yeah, most of you seem to be doing well, submitting quizzes, labs, and all that. On to today, though. So there are two last tree topics that we have to talk about, which are AVL trees and 234 trees. We're going to try and talk about those on Thursday, though. What I would like to talk about today a little bit more is GDB. So GDB is a debugging tool for your code. So currently when there's a problem with your code, you riddle your code with print statements, right? That's what you do. You like put a bunch of print statements in there. GDB is like a bit more of a less straightforward, but definitely more powerful way to try and debug your C code. This is a new lecture. This wasn't really in the course previously. What has been in the course previously that we're using to help you debug is, if you kind of go to the labs, there's actually this week 11 lab, where in the lab, it actually is an entire lab on debugging with GDB and Valgrind. And it's very prescriptive, and this is actually what we're going to be going through today together. Not every single part of it, but we're going to be like kind of using this as a bit of a template to play around with things. Yeah, the point is there's a lab here. This has already been here, but we thought we'd give it some lecture time. So that's what we're going to be going through today. It's just a little bit more of a demo on it. This also takes some effort in terms of how'd you put it? Like, it just takes more time to do. So I see in the chat that Hamish says after you learn GDB, you'll still litter your code in print statements. So that's true. I still mostly do debugging with print statements, but also there is a certain level of like, GDB is really helpful where you don't know where the problem is. Like, print statements are really useful if you know where to look. Using print statements to figure out where to look is a really hard thing because you have to put them everywhere. Waleed and Diorora say, will we touch on assignment 1 today or Thursday? I'm not too sure. We'll touch on it sometime, either today, Thursday, potentially next week. I mean, the assignment itself is actually very well written, in terms of like, I didn't write this assignment, right? Because this is me coming onto the course for the first time. So I didn't write it. We modified a couple of things with Kevin, but fundamentally, like, you read it and it makes sense. I read it a couple of times in 15 minutes and I was like, okay, I get this. And then I poked around the code and I was like, okay, I don't know how to solve this off the top of my head, but we'll figure it out. So I think we will talk about it. And I think what will help is that as people kind of ask questions on the forum, it'll be obvious as to like kind of where the issues in understanding are. So we will talk about it at some point. But don't feel like you can't start it. I know there's some students that kind of have this feeling like, oh, if I don't get walked, if I don't have it read to me, then I can't understand it. It's like, pretty much just open up the assignment. You can get it on WebCMS3. It's all here. Read it, and if there's anything that you feel is unclear, post on the forum about it. Yeah, particularly another thing is that in my experience, going through an assignment is a lot more valuable after people have actually looked at it. Because if you kind of go through an assignment when no one's looked at it yet, then it's all misty to them, right? Like when you look at this, if you haven't seen this before, you're like, oh, that's a lot of words. And if you kind of just go through it, it's like, oh, it's a lot of words because, you can't spend like an hour going through it, right? So check it out. We'll talk about it, I promise. I just don't know whether today, Thursday, next week. We might even drag Kevin in to talk about it because Kevin's been part of this course for a while, so he might even be able to give some pointers. But we'll support you however that happens. And the important note here was that on the forum, so Kevin's made a mega thread here, where essentially, so a mega thread in Ed is basically a thread whereby whenever you make a comment, it's like we can essentially individually track them and resolve them. So you can see here there are 2 that are resolved. Max has made a post here. And, me, Kevin, whoever will answer that, probably Kevin, he'll get to it before me. And this is really handy because what we're essentially asking people is like, if you have any clarifications needed, then we want you to post in this mega thread here. So for all assignment 1 related questions, particularly to do with like clarifications, not my code doesn't work, I don't know why, but like things like these are good questions. Like, sorry, do we meant to add something here? Like this doesn't work. I'm a bit confused how we start testing. The really good thing about this is that you can go and have a look at this mega thread to get all the answers you need. You don't need to kind of troll through the forum. So that's the other reason we're doing it, because and I get these questions about going through the assignment. What's really helpful is that in my general view, when you read an assignment like this, 90% of it will make sense, and there'll be little niggly things that you're just like, I don't quite get how these 2 things relate, or like, these 2 files, is this a separate, you know what I mean? You'll have these strange questions, and they'll often be answered in the forum already, and if they're not, you can ask them and we can get them answered. So check out assignment 1. It is due in 3 weeks, or 2 weeks, 6 days, on the, I think it's due up the top, Friday the 16th. It's due even longer than that. Oh, I'm so generous. It's due so long. It's 3.5 weeks. My goodness. So, yes, it's due on Friday of week 7. It's a 1% off penalty for every hour late. So, yeah, I think we opted to have a Friday due date, 8 p.m., and then a more gentle late penalty. So yeah, Friday of week 7. It's pretty incredible actually that like you don't have assignments due in this course till like the end of week 7, basically, like 2/3 plus through the term. But you've got week 4, week 5, flex week, and week 7 to work on this. I would definitely recommend starting. I don't believe there's any information you're missing. Most of what you need to do this assignment is just your general knowledge of C programming and a little bit on data structures. But yeah, we'll talk about it. Key thing for now, go look at the spec, check out this forum thing. It's pinned up the top here. And yeah, okay, let's get into the GDB stuff. All right. So, we're going to be learning about GDB and Valgrind in this lecture because print statement debugging is not a very scalable solution. Long programs is 2 words, that's not a new noun, but using print statements works fine in really simple programs. Also, the other problem with print statements is that it can get pretty complicated for like recursive structures and stuff. So we just need a better way to do all these kinds of things. The basis of this lecture, as I said, is based off this Lab 11, which you can find just by, it's also at the bottom of the Tutes page down here. You can get that easily. And the lab isn't marked. Even though it says Lab 11, it's not a marked lab. You don't get any marks from it. How would you put it? We're not going to mark you on it. You don't have to do it. But what I am saying to everyone, and I've said this to your tutors, is that if your code doesn't work, your tutor is allowed to say to you, have you tried debugging it with GDB? And if you say to them, I don't know how to use GDB, they're going to have expected that you look at the lab, if that makes sense. So while I say no one has to do it, effectively the point is if you want to get help from people in this course, you should do this because your tutors aren't expected to teach all of you GDB individually. So that's why we do this lecture. That's why we have that lab. It's all written up here. You can go through it. So yeah, labs and help sessions. If you want help, make sure you do this lab or have watched this lecture. I guess you're already here. But let's start with GDB. So GDB is where we'll spend most of our time. Valgrind's a second tool, which we'll spend a little bit of our time. GDB is a portable debugger that we can use to debug our C programs. It works on other kind of C-based things like C++, but generally speaking, most of the time we're interested in it for C. Just make myself a tiny bit smaller. What GDB is you have to think about it like it's essentially this kind of omnipotent godlike figure that watches your program run and keeps track of things and kind of can slow it down and pause it and like manipulate time and everything else, right? So it's a big parent that watches a program run. When we want to use GDB to run our code, we have to compile our code with the -g flag. What this -g flag does is it essentially tells GCC when it's compiling your code to add a whole bunch of metadata, what they call like build symbols, to your executable so that GDB can track it, right? Because normally like a compiled code like an executable, its primary goal is to run efficiently and quickly. But when you want GDB to kind of monitor your code, your executable, and keep an eye on it, you need some more information in your executable. The way I've written this in the slide is like, think of it like littering your code with print statements. Like when you put print statements in your code, it gets compiled into your executable, and then when you run it, those print statements print out, and that allows you to watch your code and make sense of it. The -g flag, when you compile with GCC, is kind of the same thing, except it's not print statements. It's all fancy magic that GDB needs your code to have. So just to be clear, GCC and GDB are different things, right? So like GCC is your compiler, and when you do the -g flag, it compiles it to an executable, right? When you do a /. GDB is a separate program. And what GDB does as a program is it runs and watches your executable. So GCC, GDB are different, but you need to use the -g flag when you compile with GCC to allow GDB to watch your code. Matthew says, does this come with Linux or something? Yes, it does come with Linux from the best of my memory. I mean, I guess so, GDB. No, it does. I don't know. I just tried to run it on Ubuntu and it says I have to install it. But it's easy to install if it's not. And as Matthew said, like most IDEs will sometimes have these easier to run. So like you can kind of integrate GDB with VS Code pretty simply. We're not focusing on GDB and VS Code in this course. We're just focusing on you working on the command line with it. Yeah, but let's actually look at running some stuff. So before we even get into a complicated example, I would really like to show you just how you would actually run a program with it. So I'm going to make a really simple C program to start. Oops, sorry, I just hit the button. I'm going to make a really simple C program in VLab called program.c. Okay. And inside of this, let's make a new folder for 4.1, because, God, we're going so quick through the term. And let's make a really, really, really simple C program. What do you want the C program to do? Someone give me some interesting ideas. No one's interesting ideas from anyone. Hello world! You're all so excited. Someone wants to print 2 + 2. Okay. Find the square root of an integer. Calculate the meaning of life. Solve assignment 1. Goodbye world. While 1. Okay, that's a great list of ideas. Good luck with the assignment, but one character at a time. Oh, okay. I like that one. Good luck with the assignment, and let's print one. Let me save this as a file first, program.c. We need that syntax highlighting. See, doesn't this feel a bit easier and nicer than trees? Let's find the length of this string, right? Let's just take a quick tangent. S length is string len of s. I haven't used string length in a couple of years, so I'm probably using it wrong and I have to look it up. And then we can just have a little loop where we're going to print out s length, and we'll just do a printf of a character per line, say. Let's try that out, and we'll do s of I. Am I missing anything there? Print an ASCII circle. I probably haven't done this wrong, but if we were, to compile this with GCC, we would use these flags that you're familiar with, program.c. And we would run program, and it surprisingly it worked. Okay, so good luck with the assignment. That's nice. That's a nice little program. Now, how do we run this with GDB? Well, GDB doesn't work on your source code, right? GDB does not look at your, how would you put it? It doesn't look at your C code. It looks at your executable. So like in this folder now, I have program and program.c, and it looks at program. So when I run program like this, what GDB is it's a wrapper that essentially runs that program for you. So if you want to run your program with GDB, it's GDB, and then you actually give it the executable to run. So you got to think about your program running and GDB wrapping around it, keeping an eye on everything. When I try and do that though, what happens is that GDB has now started running. It's kind of like opened up. It's a bit like a shell command. Think of it like, when you SSH into something and it gives you like a new little terminal. It's kind of like that, except it has nothing to do with SSH. And this is my GDB. You can see I'm in GDB because it has this little GDB bracket here. So it's essentially saying you're not sitting on VLab anymore. You're in this kind of sub-terminal. And now I can do things. Now, one of the first commands we're going to look at together is this run command. That actually runs your code. So what GDB does is when you start using it and you say, I want to do GDB on my program, GDB doesn't run it. It actually just gets ready to go, right? It goes to the starting line of a race, ready to go. And when you type run, it's like go and run to the end, go execute everything in the program. And when I do that, it runs. Now, I'm just trying to find something. So you notice here that this program, it ran. And I said to you before that when we compile with GCC for GDB, we need to use the -g flag in the compilation. Now, this still worked. And a big part of that, as far as I understand, is because we didn't actually ask GDB to do anything interesting there. Like, it's a bit like, imagine if I told you to debug your code and all you had to do was like start the program and finish the program and not look at anything. You wouldn't need the print statements. So what's happened here is GDB's tried to run your code without any debugging symbols. You can see that there. It's like it's trying to read all the GDB magic from your code that it was hoping was embedded there by GCC, and it says none were found. But it didn't stop your program running because those symbols are only used for GDB to debug your program. It can still run your program fine. So when I run it, it does that, but I compiled it wrong. Now let's try compiling it with the -g flag. So when I go to run it again with GDB, I open up my little GDB subshell, and then when I type in run, it runs it. And you can see the main difference here is this one, it just said reading symbols. So you can tell it's worked here because GDB said I can read your symbols now, essentially. And it's run it for us. And it's also exited normally. So it says it got to the end of the program. Now, what's also important here is if I type run again, it will just keep running my program for me and keep printing things out. So Caleb says, kind of like how DCC works. Yeah, I think conceptually it's a good way to it's a good way to kind of understand how DCC works. Is DCC, there's this, it runs to executables and all this stuff, but essentially DCC is just a C executable wrapped in some kind of layer that's keeping an eye on things. And that's how you get these really nice errors, because when you do something silly with a DCC compiled executable, there's that Python script that's watching it, and it notices when you do things, and it can give you better messages about it, because it's kind of keeping an eye on it. So the actual executable doesn't give you those errors. It's that thing that's watching it. And yeah, it's a Python executable, whereas like GDB's it itself is a C executable. It's written in C, I believe. So I think it's written in C. I'm not sure. You know what blows my mind? It's always blown my mind, the fact that GCC is written in C. So like, when you want to make a new compiler, when they like upgrade GCC, they literally compile it like this. They're like, I'm going to use GCC to compile this GCC source code into a new program called GCC2, and then that's your new GCC. It's a really cool bootstrapping idea. Diorora says, can you pass GDB to GDB? I can't see why you can't. Yep, you can. See? So GDB is just a Linux executable. And our C program that we compiled is just a Linux executable. So we're actually just using a program that's written, GDB, which is a Linux executable, to keep track of another program that we've written called program. And in this case here, I've just tried to run it. It's pretty trippy, right? So I'm running the GDB checker with GDB, which means that this what we're getting here is the GDB subshell. So it's like, oh, GDB is so ready to analyze GDB. And then when I do run, it's actually going to run the executable here, which is why we get another subshell, which itself, if I tried to run it, would probably say that there's nothing to run. Yeah. And then if I when I quit it by I think it's exit. Is it exit? Q? Yeah, it's Q to quit. And then Q there. Just reading the chat. Yeah, so that's GDB. That's the gist of it. Now, it's really easy to compile with GDB and run it. The hard thing is actually how to use it. So I've got all these commands here, such as run, continue, break, next, step, and print. Now, this lecture is not going to go through things in as much depth as the lab does and will, but we will try and let me move my head up the top. We'll try and like cover the basics. So first thing you'll notice is that all of these commands here have a shorthand version of them. So instead of typing break, you can use B. Instead of typing next, you can use N, and step is S, and print is P, and R is run and stuff. So run is R. So if you're feeling lazy, you can just use these shorthands instead of the actual full commands here. I'll probably try and use the full commands just so you can really see what we're doing. But let's have a look at some of these items. So the first one is run. Now, how you kind of have to understand GDB is that your C program is essentially just a giant marathon that your computer runs, okay? You start up here, this is the beginning of your program, at the start of your main function, and down here is the end of your program. And what your program does is, it kind of does some stuff, and then it makes a decision, and it goes this way, and then maybe it does a couple of loops like this. And then when it's done those, it comes down here and it makes another decision, and then it comes and does this. But it's always generally, it's always a sense of a start to a finish. Unless you have go-tos in your code in which you're a monster. But it's usually speaking, it's a very linear, maybe there's branches, maybe there's loops. But it's start to finish. And what GDB's job is to slow this down and to keep an eye on things. I'm just trying to make some eyes here, but I'm not doing a very good job. So this is GDB. Should really do this properly. So GDB is just hanging out here, trying to make sure that such a funny face. It's I can't tell you how how terrible my drawing skills are. So this is perhaps the best face I've ever drawn in my life. Let's do some eyebrows. So GDB is essentially watching this flow happen, right? It's keeping an eye on all the key points here. And what your job is as a GDB user is to essentially help GDB define these key points. God damn it. Define these key points in your program where you want it to stop and GDB to look at things. If anyone's ever, has anyone ever trained someone, like everyone ever taught a sport like soccer or tennis or football or just netball or anything? It's like, you know that, you know, when someone's trying to do something, like say someone's trying to throw a ball, you know, they just pick up the ball and they throw it, right? It's all like one foul swoop of motion. But if you're trying to like train someone or like debug their skill, you kind of pause them at various points, right? Like you say get set up, and then you check, is that all good to go? And then, you know, you throw it, and then you hit it, and then, you know, you look at where it is at the end. So GDB is very similar in the sense that debugging, it actually wants your code to stop at certain points to check things out, essentially. But if you don't tell it to stop anywhere, it just goes like straight through to the end. And it does that instantly. So that's why, oh God, sorry. That's why when we're here and we run GDB on our program and we type in run, right? So right now the program's up here, and when we type run, it's just going to race to the end, and then it gets to the end. So that's what happens here. It races and it gets to the end, and we want to stop it because this is useless. But I'll show you how to stop it, which is like first in our C program, let's pull out our print function into a completely useless function. Let's create a void function called print char, which is going to take in a char, and all it's going to do is just print the char like this. And then I can call print char with my s of I. So to make our code stop, to kind of, I'm going to close this one, I keep clicking on it, to kind of make our code stop at various points, like here and maybe here, you can set as many points as you want. We're going to create breakpoints. Now breakpoints are a really important part of understanding GDB, and what breakpoints are is they're essentially a point that you're saying to, you're kind of telling GDB, if you reach this point in my code, this breakpoint, I want you to stop there until I tell you to keep going. So take a pause so I can inspect things. So you might say, okay, I want you to actually stop here. Or like stop here. Again, oh, no, the eyebrows. Yeah, so I want you to stop there. We do that by typing in break into GDB and then either giving it a particular file name and line of code, or we give it a particular function name. Both of those things are fine. Like GDB just needs to be told where in the code things are. The other thing you'll notice here is that the reason that you need to compile with GCC is that if you try and think about it, it doesn't make sense that you could look for the line set.c 122 in an executable. It's been compiled, right? Like when you open an executable, there's no source code there. It's all the compiled stuff. So when you compile with -g, this is what these debugging symbols are. They are information about your source code that's kind of baked into the executable. Jiao Yi says, is the breakpoint like insert a print statement? Sort of. I don't want to say it is, because like if you did a breakpoint and then printed things, that's like a print statement, but it's a similar kind of thing that when you write a print statement, you're essentially saying, this is a really interesting part of my program that I want to stop at and learn more about. So think of a break as kind of like the place you'd put a print statement before you actually put one there. Let's give it a hat. No, I don't want to give it a hat. It's going to look weird. No, we can give it a hat. So we're going to use breaks now, and I'm going to break on particular parts of my code. So I run GDB with program, and then before I run it, I'm going to tell it where I want it to stop. And I'm going to first try the method where I just give it a function name. So I'm going to say I want you to break on the print char function. Now, thankfully, in your C code, you cannot redefine functions. We've learned this. So there's only ever going to be one function called print char that was part of your source code that ended up being compiled. Just one. So when I type in break print char, I press enter. GDB says it's not defined. Oh no, why is that? What have I done wrong? Did I recompile it? Did I forget to do that? Maybe I forgot to recompile it. Break print char. Yeah, okay, I forgot to recompile it. Oops. So now it says breakpoint 1 at gibberish file program.c line 5. So it's actually aware where this is. So I could use break program.c print like line 4. You don't really need to worry about this line 5. Well, line 5 is like the first line of the function, but I've made that breakpoint now. So what happens is, I want to redraw this diagram. Think about how our program actually works. Our program starts at the top. It does a couple of things, right? It sets up some strings, it gets some whatever, and then it enters a loop, and it essentially does this 12 times. And each time it loops, it branches off and calls like another little function. And then once it's done that loop, it goes and finishes the program. Right? So this is like our print char here. So that's the flow of the program, right? It comes down, it goes loop, 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 loop. I don't know why I said 12 times. That's totally weird. It runs more than 12 times. It runs a bunch of times, n times, for the length of the string. And then it prints the char, calls that function each time, and then it finishes. So what we're doing by putting the break on the print char, we're saying, okay, every time that function's called, stop. So now when I run this, after I put the break, I type in run. It says starting program, and then it says breakpoint 1, and now it tells me exactly what's happening here. It's saying you told me to break, to pause, on the print char function, and I'm telling you right now that I've stopped there. This function's just been called. I'm going to pause the execution of this code, and the argument that it's been given is the value C is 71 as an int, which is the character G, which is this good luck here. And then it says that the line that, I can't remember if this is like the line that's just been executed or the line that's about to be executed is the printf. But it's essentially saying this is like the line of code we're at now, is this printf. So because you called the function, we're at this line of code. So we've stopped there. And then when I type run again, it's basically like, sorry, but the program's already started? What do you want? Like, I've already started running it. Now, that's a very subtle difference here between run and continue. So both run and continue are about executing code until you reach the next breakpoint or the end of the program or your program crashes, right? If the end of your program is the end of it, if your program crashes like it's seg faults, then it's the end of your program. But run always starts from the start. So run's what you run the first time when your program's ready to go. And if you try and use run again, it's going to try and rerun your whole program. It's going to try and come back up here. But you don't want it to come back up here because it's already taken a pause right here on the first loop as it's going through the loop's first loop at print char. So what we say instead is continue. So when you're already at a breakpoint, when you're already at a pause and you want to keep going until another pause or the end of the program or some kind of crash, that's when we use continue. If you don't put any breakpoints in your code, I'm not really sure what the value of continue is. But let's only click no because I don't want to start from the beginning. So I've broken at that line, I paused at that line, and now if I do continue, it will run again. It will keep going through the program until it gets caught at another breakpoint, which is the exact same breakpoint here of this line here. So it's gone and executed all of that, and now it's at the O, because you can see there the character that's been passed in is 111, and that's the O, the second character there. So what's happened is when I've hit continue, it's gone, oh, great, thanks, I'm going to go back through that loop, and we're going to print oh, there's another breakpoint. So it stops right there again. And I could do this for all of the characters, like this, and that's a second O, and I'm just going to use C here for some, well, I could just press up, continue again, good luck, assignment. And then we get to the N and we get to the T. And then after we, so this function's now called with the T. What's it called with next? Nothing, because the program finishes. So that was the last loop here. And because we got to the last loop, we got to the return, and then the program finished. So that's the crux of run, continue, and break. Run and continue are about telling GDB to keep going until a breakpoint, crash, or end a program. Break is about telling GDB these are the points to pause at. I want you to totally pause, freeze time, so that we can, learn some things. You can put many breakpoints in your code. We'll do that quickly now. If I exit GDB and I open it up again, I might say break on print char, and then I also might say, just for fun, let's break on program.c line 9 or line 10, for instance. Okay, so I'm breaking on those 2 points now. So I've essentially said I want you to break early on, and then I want you to break on this function call here. So now when I run it, the first time it breaks, it says I've paused in the main function, and I've paused ready to execute line 10. This is the line I'm ready to execute next. And then when I when I type continue or C, it's going to keep going until the next breakpoint, like this. And then it will again run through the program normally. Now you can also remove breakpoints. I don't really remember how. Someone probably does in the chat. But what is it? Is it D? Is it delete? I can't remember. I haven't done this for a long time. Someone's probably going to tell me. Delete 1. Oh, sure. What does delete 1 do? Deletes the second one, does it? If I do delete... Oh, yeah. Okay, so... Did it delete the second one? Because it seems to still have the first one. Info break, though. Info break. Cool. So Kai's just said in the chat, this is really useful. You can actually see the breakpoints here. If you type in info break in GDB, you'll see the different types of breakpoints. If I want to add a breakpoint to print char, then it'll add it there. And if I run info break again, you'll see these ones. So it says that the current breakpoints here are program.c line 10 and program.c line 5, and it tells you what it is. So this one's the print char function. This one is just, these are the functions that's inside. And if I want to delete a particular breakpoint, I just say delete 3, and that will delete that breakpoint. Generally speaking, you're not going to do a ton of breakpoint deletions. The kind of realistic way that like a normal person will use GDB is you'll just be rerunning it, kind of the same thing. You don't have to get too advanced with it, because many of you will still end up defaulting to print statements anyway. What in God's name? Okay, that was weird. So, next couple of commands. First, print, because like so far this all seems pretty useless because we haven't done anything. Print is where you can print out the value of variables. Now, write layout next for better visuals. Sure. Ooh, that's so fancy, isn't it? Come back to that one. So when it comes to GDB, the main reason you actually use it is to print the value of things during a breakpoint. So let's say I put in a breakpoint on print char, or let's do it on break on line 11. Now I run my program. It's going to break on line 11. So it's just executed line 10 here. It hasn't executed line 11. But I want to check what in the world S length is. Okay, I don't want to like, maybe I've got it wrong. Maybe I'm wondering if there's a fence post error here. In fact, maybe let's make this smaller. Like, let's just make this hello. And then I'll recompile it. Q for quit. Yes for Y for yes. I recompile it. I run GDB. I do a break on program.c line 11. Great. I run it. It pauses, ready to execute line 11. And now what I can do is there are a bunch of variables in scope that I can print. Now, was it list? Oh, no, it's not list. What is printing, what is it? GDB list of variables. What is it? Thought it was list. Info variables, right? Dumb. Is it info? Just info? Oh yeah, it's too big. Q to quit. Info variables. So many variables. What have I done wrong? Forgotten this tiny thing. Locals, right? Is it locals? Thank you. That's it. Info locals. So when you are paused, so we're paused at a breakpoint here, right? I know I printed out a bunch of crap, but if you actually scroll up, we hit a breakpoint right here, just before this for loop. So we're paused on line 11. And what I want to do is figure out all the variables that I could print there. And when I type in info locals, it tells me all the local variables that exist inside this part of the stack frame, my function call. And it says I've got this variable I, which is set to 0 here. I've got this variable S, which is a string. That OX5555 thing is an address to the beginning of that string. And then it says S length is 5. Now, I don't always need to type in info locals. I could also just type in print S length. And that will tell me what the value is there. So I don't need to riddle my code with print statements here. I could actually just figure out what everything is just by typing in a whole bunch of different stuff. Yeah, so that's pretty handy. Printing is kind of the essence of why you do this stuff. Like you break at key points you want to learn something from. And then you print out the values at those points. That's really why we're here. So if I wasn't sure what something is, for instance, and I had a char adjusted char equals C+2, and I was printing out adjusted char, and I wanted to kind of debug what was happening here, then if I recompile that and I run it, I could say, again, I could break on print char, right, and run my program. And then I just go, okay, I want to print adjusted char. And it gives me this weird value. Why does it give me that weird value? If I list locals, or info locals, sorry. Ugh. Info locals, it says I've got this adjusted char here, which is 0. Does anyone know why that looks like 0? I would have expected that to be a number, right? Like char should be, because what's that? That's null? Not null. It's just 0. But I passed in a character that H, so it should be the ASCII H. So Halogen, a couple of people have said this. So Halogen's kind of nailed this one, which is that the line hasn't been run yet. So when you break on a particular line, or if you break on a function, it kind of breaks on the line at the first line of the function. It's getting ready to execute that code. Now again, I'm not super across how all the inner workings of a computer are. That's not my day job, but essentially here it looks like that the either GDB or the compiler, this variable's been set up in some way, but the line's not actually being run, or it's just a false thing. I'm not really sure why it's 0. I personally knew this wouldn't work. I knew this wouldn't work, but I personally thought it would give me an error. Just because hasn't run the line yet, so how would it know what adjusted char is? But the real question is, how do we actually get the value of that adjusted char? Well, you could break on the printf line, you could break on like program.c line 6 if you want to, but that's not really a scalable way. Like if you want to pause the program at a whole bunch of different points, you don't want to use breaks for everything because that gets really cumbersome, and you'd have to restart the program in some instances if you've already gone past what you're interested in. So breaks are about putting these big crosses on the key parts of the program we want to stop at. But if we stop at a particular part of a program, say here, and we simply want to learn what's next, or maybe what's next, or we want to do what we call like stepping through the program, then the last two commands we're interested in here are next and step. Now, generally speaking, both of these are used to step through a program, but next is the one you're more likely to use. And the reason for that is that next doesn't go deeper into functions, and step does. And I'll give you a demonstration of these, but for now let's use next. So I've paused my program just before line 5's been executed. And if I want to execute one line of code, I type in next and it will execute one line of code. And you can see there it's moved down. So it's gone from char adjusted char to printf here. It's gone there to there. And now it's like, okay, now I can print out adjusted char. So I could say info locals. I could also say print adjusted char to see what it is. And I can see that, it already printed out for me. But you can see there it's J. So this is really helpful because now I'm like, okay, well I can see it's J. So it's HIJ. Okay, so this is exactly what I expect. It should work fine. And then maybe I type in continue because I want to, keep going. And you can see my program's printing out J, G, N, Q. Q? Yeah. Yeah. Yes. I forgot the alphabet 2 days ago. I was just sitting at my desk and I was trying to just like recite the alphabet. I don't know why. And I just couldn't finish it. I got stuck around M and it was the strangest experience. I was like, am I having a stroke or something? Anyway, I figured it out a few hours later, but yeah, it was weird. Super weird. Thanks for listening. So what we have... brain filters out useless info. So next goes through line by line of code, and let's look at this. So if I restart my program, and I don't put any breaks so I just restarted GDB. All your breaks disappear, by the way, when you rerun GDB. There's probably a way to keep them persistent. I don't know what that is off the top of my head. Honestly, I don't really use it much. Because when I'm debugging programs, typically I only put like 1 or 2 breakpoints in, which take all of half a second to write. Though I think in theory, like the way you're meant to do it is rerun the program. Like if you want to keep the same break statements and stuff, you just write run again. So, you put break here like print char, and then you run it, and then it, you continue it, and it finishes, and I think you can run it again. Yeah, it'll just run again. So essentially once you quit GDB, it's like resetting it, which is useful in some senses, but the point is, I want to open GDB here, and I want to just set a breakpoint for line 10, or main. Let's just break at main, right as the program starts, which will be like line 10 here. So now when I type run, the program starts, and it stops at this line here. Now I'm going to show you what next does. Next goes from line 10 to 11 to 12 to 13, and then to 13 and 13 again, because it gets caught in the loop, and then it'll eventually get to 15. So I go next. So now we're at int S length, I go next, now we're at the loop, I go next, now we're at print char, I go next, now we're at the loop, I go next, now we're at print char, I go next, now we're at the loop, and you can kind of see. So next is a really great way to understand the flow of your program as you intuitively understand it. And then we get to the end here, return 0, and then it says the program's finished now, essentially. So that's what next does. Let's take a look again, but let's use step instead of next. So I start on line 10 and I do step. Step moves to line 11. That makes sense. I do step again. Now some weird stuff has started to happen here. I don't know why it's doing that. Some genius want to tell me, that's so weird. This is going to be some really random thing. Anyway, without getting caught up in the thing just while someone probably tells me what that is. What step does... You're stepping into string length's fine. I wouldn't have thought it would crash though. I've done this before. So when you do step, what actually happens is it goes and executes the next line. But if that line tries to actually access a function, basically go deeper into the call, it will do that. So in the case of this line, like here it goes, okay, this is just a simple line. This line here has a function. So then it's going to go inside the function. It's going to go keep climbing down the ladder. Step kind of more closely emulates the exact workings of the computer in the sense that it's actually going through everything, because when you call string length or even printf, it's a lot of complex code that it calls. It calls an actual library function that's very long and complicated. Whereas next will go to the next line of code, but next will never go deeper into a function. It will always it will never move a level deeper, because your code is it's a function here. Well, if you imagine this is your main function, which is made up of all these lines of code. But then if this one is string length calls another function here, which is made up of all these lines of code, which might call more functions. So essentially step just kind of goes through the entire tree, if you will. Whereas next will not go any deeper than this main function here. There's probably something subtle. I have stepped into library functions before. Like I thought you could step into printf. That being said, I haven't done this in a few years, so maybe it doesn't work. But if I try this one again, and we compile this and run this, and then I just break it main and run it, and I step, okay. Maybe I used to compile them differently or something. I've definitely stepped into library functions before. But anyway, that's why you're getting the error, because it's trying to go inside a printf or trying to go inside a string length, and it's just like, what the hell's that? I can't find it. It's basically saying it can't find it, which probably has something to do with that it was never, the source code wasn't compiled with the G flag or some weird thing. Yeah, so Waleed says, what if you call next while inside a function and then the function ends? Can next get back out of the function? Yeah, so next and step are pretty much identical. It's just that next will not go deeper. Both of them will just like do the thing, but next will just never go deeper. So I just want to show you this last thing. And then we'll take a break. Maybe we'll chat then through what would you call it? The lab briefly, and then maybe we'll get started on trees or something. But yes, let me show you the step thing. So if I run this program now, and maybe I'll just get rid of this printf here for a sec. So unused variable. Forgive me everyone, but I'm going to get rid of the warnings. So now when I run it, and I want to break on, say, line 11. Watch what happens when I run next. I gotta run. Okay, it breaks on the loop. Next goes print char, loop, print char, loop, print char, loop. It doesn't go inside the print char function. When I run, and I break on the same line, and I go step, it executes the loop line. It then executes the print char line, but because there's a function there, it goes inside the print char function. You can see it saying that, and then it goes and executes all the code inside there, and it gets to the end of the function. Then it goes back to the loop. So it's actually going into the print char function and finishing that and coming back up. So it's going as deep as it can, and that's why stepping is the same thing, but there's just more, steps involved. Yeah. Exactly. I hate unused var errors. I'm going to use it later. Leave me alone. Yeah, you can totally turn the warnings off while you're deving. Just make sure, we're just going to compile your code with it at the end. So it just needs to work at the end, right? That's all. Yeah, so Kai's made a good point too, that you can leave W all, because remember that warnings all just displays warnings. Warnings error converts warnings to errors. So warnings all will still give you warnings, it just doesn't stop the compilation. So this actually successfully compiled, right? We can try this out. If I remove program and then I try and run this, and then I type in ls, it's actually compiled. So a warning is not fatal. It allows your program to actually build an executable. So if the errors are annoying, I'd more just suggest you leave W all there, but get rid of W error, because then you'll still have the warning messages, which will be good because it'll help you not have your code go crazy, because you probably, if you have 30 warnings, you probably really should stop and write better code. You'll probably trip over yourself. So let's take a 5-minute break, and we'll have a little bit more of a look at GDB for a little bit, see how we go. It's a new lecture. I'm not really sure how long we want to spend on it. Then we'll probably talk about some trees, maybe just some AVL trees for fun. They're going to be very conceptual. That'll free up some time on Thursday. So anyway, let's take a 5-minute break, and then we'll keep going. Hope you enjoyed your break. So that pretty much covers everything about GDB. I kind of talked through all this with the flows and stuff. I kind of think that I might not do the lab. I was originally going to go through the lab, but I mean, I think it's so well written generally that like you can just kind of go through it. If you really struggle with it, you can always like, chat about it. I think the only real thing I'm missing from GDB that's quite critical is that, primarily speaking, the main reason you use GDB is to debug seg faults, because seg faults are really tricky things to debug. And typically when you're debugging your code with GDB, you're looking to make sure you're trying to really hunt down instances where pointers are null. So I know that wasn't quite the example I went through because we just wrote a random C program, but if you get a seg fault, most of the time it's because of a pointer, right? Seg faulting is a pointer to an invalid address in memory, which typically either comes from an out of bounds access, as in if you're accessing a memory address way beyond an array as allocated, or if you're trying to dereference null, because that's not a valid memory address. So a seg fault is a crash in lieu of an invalid memory address. So the primary use case for GDB is on complicated code where you want to try and figure out where it all went wrong, because seg fault means something's gone wrong with a pointer. You try to dereference a pointer that's bad. So that's kind of why you'll often mainly use it. Like, they don't teach it in 1511 anymore, I don't think, but we used to teach GDB in 1511, and we mainly taught it when it came to the linked list components. So we typically teach it with linked lists because that's the first time you really need it. Because remember, all those DCC is a bit more helpful, but like all those weird errors you get with linked lists are all to do with strange pointers. Like you haven't allocated the next pointer correctly, and blah blah blah. So often it's mainly useful for trees. Sorry, I just read a question about trees. It's mainly useful for lists and any kind of pointer-based structure, which can include malloc arrays. Waleed says, a small question. It seems like self-balancing trees would be very useful in the assignment. Will we learn it? Well, not really, because we kind of already did that last week. Like, a self-balancing tree is just a tree that either inserts at the root, because that can lead to a more balanced tree, or it's a tree that partitions itself semi-frequently and stuff. Like, when you rebalance is maybe a question. Just, you can rebalance frequently, every time, sometimes, every random thing, every whatever thing, but last week was mainly focused about the actual how to rebalance trees. So no, we're not going to be doing much more on... Well, we're going to be learning about two types of tree structures that have pros and cons. One of them's to do with balancing, but there's no real specific topic on self-balancing trees, because you could have a tree that balances itself every time something's added. Before we get onto trees, though, I just want to tie off this topic by talking about Valgrind. Now, Valgrind is it's very simple. Valgrind is a program like GDB that tries to detect any memory leaks in your program. So essentially, every time you malloc something in your code, Valgrind keeps an eye on it and sees if you freed it. So if you don't free it, Valgrind's like, hey, you didn't free it. And this is important because from kind of now on in this course, with your assignments, we'll be running Valgrind on your assignment. So essentially, if you don't free your stuff properly, Valgrind will pick up on it, and it'll get mad. It'll be like, don't do that. So let's use it. Really simple to use. You have to compile with -G because it needs the debugging symbols. So we got our program here. We know it runs, prints out nothing because I got rid of that printf. Let's put that printf back in so it's a bit more fun. It prints out Jigunqu, and if I run it with Valgrind, it prints out Jigunqu, but it has all this other funny stuff here. It says memcheck, a memory error detector, copyright, GNU, blah blah blah, using Valgrind command heap summary. All heap blocks were freed. No leaks are possible. This is the stuff you want to see. You want to see that beautiful line here that says all heap blocks were freed. Because remember, malloc allocates memory out of the heap, which is a user-managed section of memory. It's not a program-managed section of memory. And if you have memory leaks, there's a problem. Now, one thing that's important to note again, remember, the operating system always frees the memory of your program after it's terminated. So if you don't free things and your program ends, it's not like memory's lost forever in the computer, because the actual it's only a problem during the lifetime of the program. So sometimes you won't notice memory leak. Sometimes a memory leak will cause your program to crash because it actually runs out of memory during the process. Sometimes your browsers do this, right? I think we've talked about this. Like some web pages and stuff can consume memory without freeing it correctly. So like sometimes you'll have a web page that's been open a really long time and it's actually chewing up a lot of memory because there's memory leaks in it. So Valgrind tries to detect when there's memory leaks that basically weren't freed. So let's make this string a malloc string now, just for fun. So instead of this, I'm going to say, actually my char string will be malloc size of char times by 6 because we want the null character. And then I'll do string copy, which I forget how to do off the top of my head. I know it's the two things, I just can't remember the order. I don't know if it's like A to B, destination and source. I would have got that the wrong way around. So the destination here is S and the source is just going to be hello. And I think that should work. Oh, we forgot to include stdlib.h. Someone said only assignments will be valgrinded. So the labs might be too. I just don't remember off the top of my head. Sorry, I was just being like trying to be the main thing. So if it's written in the lab, then it's written in the lab. I just don't. So a lot of these labs, previous labs, and Kevin and I just go and tweak things. Like we've moved some questions around and added a question here and take things out. So like I don't have an intense memory of all the lab questions off the top of my head. So, but if it's written there, it's written there. So our program runs. Now I run Valgrind with my program, and it says, where's the kind of, here you go, 2 Alex, 1 free. Rerun with leak check full to see details of leaked memory. Ooh, that sounds fun. Let's try that. Leak check equals full. Okay, so it's got some more information here. It says 6 bytes in one block are definitely lost. Okay, so what that means here is that we malloc 6 bytes because a char is 1 byte, and we asked for a memory allocation of 6 of those. So there were 6 bytes that we allocated that we never freed. So Valgrind's like, oh no, there are things missing in your code. Naturally, if we freed it at the end, and we then run this again, it's going to say all heap blocks freed. But if we don't, then it's going to complain. So Valgrind's a really simple tool. We don't really need to talk about it extensively because you essentially run it on your code and it tells you if you freed everything. That's it. And if it doesn't say you freed everything, you got to go look back through it and figure out what you did. Why is there 2 allocations? I don't know. I don't know. Yeah, like, that's true, yeah. So remember that like Valgrind doesn't really have a sense of, oh, these are Hayden's functions and these are the library functions, right? It just sees all the code. So we're calling 2 library functions in this code, which is printf and string copy, and string length, sorry, 3. And there's all the chance in the world that they actually create memory on the heap and then they free it at the end. Valgrind is not aware of this. It just sees code. So what Valgrind is probably doing here is essentially saying, oh, there's been 2 allocations, but only 1 was freed. So one of string copy, string length, or printf is going to be creating heap memory, I would guess. Some people have said I should comment out some stuff and see what it does. Comment out string copy. Sure. I don't know if I want to... Yeah. Let's just set that to be null so it doesn't break. One Alex, 0 free. Yeah, so string copy in this case is the one that's actually putting something on the heap. Not really sure why though. Not really sure what it would malloc something for, but it would malloc and free it within the bounds of the function. Someone said before that they wanted me to... can I do this on the servers? Oh, I can. Oh my god, that's so much memory. That's crazy. Yeah, just for fun. Just let's tie off this topic because that's it. Someone wanted me to do this while one do something. This program won't finish. It won't compile either. It'll be like, "Arr." Oh, it did compile. Sure. So if I run this program, someone asked for this before. If I run this and we want to malloc something. Silly. Sorry, I forgot we want to malloc something. So just a reminder about memory leaks. The reason we don't like memory leaks is because what happens is if you don't free memory, like if I just free this, right? So let's have this program. It creates a string. It loops forever, and every time it loops, it mallocs something and it frees it immediately. Okay. Now if I run this program, it will just run forever. It's just looping infinitely and doing stuff with the heap, right? And if I look at the amount of memory on VLab, I don't think this is going to change. This is kind of better when I demonstrate this locally, but I don't want to crash my computer. It's like the memory isn't changing much because all the memory that's created is roughly destroyed. However, if we don't free things, then we're basically just gobbling up more and more memory forever. And you can actually see the memory on the VLab server going down here. See that? See how every time it's actually going down. So my account was basically like just eating up RAM at that point. And that's a memory leak. You notice that the VLab servers, this is a multi-user Linux system, so the VLab servers eventually kind of were like, just kill it. So it killed the program, right? If this was your local computer, typically it will, typically it'll just, keep eating it. Sometimes your computer will crash. Sometimes the operating system will pick up on it and kill the program. If you all do it on VLab at once, it would probably cause an issue. Please don't do that. I mean, this is recorded, so I have to be on record telling you not to do that, because otherwise you all do it and then someone sends this to someone and they're like, this is his fault. But yes, that's why memory leaks are important, because if you don't have that, then either your program can potentially crash the computer, it could slow it down. Because remember, computers, when they get low on RAM, start doing funky things. So some computers low on RAM will start using your hard drive for volatile memory, and that gets really slow. So anyway, that's pretty much it on Valgrind. Valgrind's super simple. We don't really need to spend any time on it. You run your program with Valgrind. It needs the -G debugging symbol flag, and it tells you whether something went wrong. Diora says, what about code that has user input? Does Valgrind run through it or freeze? So Valgrind and GDB will, without any breakpoints, run identically to a normal program. So if you run a program with input in GDB or Valgrind, it will pause and wait for that input via a file or scanf or whatever it is. Yep. Cool.